Hello, my name is Beyza Dabak. I will demonstrate my term project for EEE474 Magnetic Resonance Imaging course term project in this presentation. Projection reconstruction and 2D Fourier transform methods are two specific 2D imaging methods. Although 2D Fourier transform method is the superior method in the field, projection reconstruction method is also important due to its applications in different medical imaging systems, including computed tomography, single photon emission computed tomography, and positron emission tomography. In this project, I investigated projection reconstruction method in detail and simulated in MATLAB. Before investigating back projection algorithms in detail, central section theorem must be analyzed since it is the basis of projection reconstruction method. Central section theorem says that 1D Fourier transform of the projection equals the 2D Fourier transform along the radial line at angle theta. Hence, from central section theorem, we can conclude that projections taken from all angles of the two-dimensional object provide sufficient information regarding the 2D Fourier transform space of f of xy. To recall back projection over a line, if we assign every point on the line L the value of g for all L, we will obtain back projection image from the resulting function. Hence, back projection image at angle theta gives information for the projection at that angle. To acquire the information from not only one angle but projections of all angles, we can simply integrate the back projection images for each angle and obtain back projection summation image. Projection reconstruction method is a 2D imaging method. Timing diagram of a basic 2D projection reconstruction sequence is illustrated. As observed from signal equation from central section theorem, the 1D Fourier transform of a projection taken at an angle theta gives radial slice of 2D Fourier transform of object at that angle. In addition, in filtered back projection, Fourier transform of the projection is multiplied by frequency filter rho and its inverse transform is taken. With outer integral, summation of all filtered projections are taken and where rho is the ramp filter. Whereas in convolution back projection, RAM-like filter is multiplied by windowing function, and here windowing function can be square, cosine, or Hamming windows. In my simulations, I use modified Shape-Logan phantom of MATLAB as the ideal image. Since it is discussed in the theory part, sinogram of the image is also illustrated here. To understand the back projection image and back projection summation image and their relative correspondence with central section theorem, first projections of the image at 0, 30, 60, 90, 120 and 150 degrees are taken. If we assign every point on the line L the value of g, then we would obtain back projection image from the resulting function. After observing the projections of different angles, back projection images for the corresponding angles are obtained, as you can see from the figures. In projection reconstruction method, these back projections are integrated for all angles to acquire information of all projections, and resulting image is the reconstructed image, which is the back projection summation image as displayed here. In the simulations of this part, 1200 projections are taken. Because the number of projections are sufficient enough, no artifact is observed in the reconstructed image. This is observed when ideal image is compared with the reconstructed image. Also, effect of number of projections on the reconstruction of image is also simulated. For this case, projections of 1110 are taken and results are compared both in sinogram and reconstructed images. As observed from here, as the number of projections decreases, artifacts are observed. The reason of the artifact is aliasing, which occurs due to undersampling. Next, effect of motion artifact on projection reconstruction method is simulated. For this, original image is shifted and inverse radon transform is taken accordingly. Resulting sinogram and reconstructed image is displayed. From the reconstructed image, the motion artifact can be easily observed. Effect of filtering and windowing functions are also simulated. As discussed in the theory part, filtered back projection uses RAM-like filter, whereas convolution back projection with windowing function with windowing functions, RAM-like filter is multiplied. To see the effect of filtering, we can compare no filter case. When there is no filter, the reconstructed image is blurry. If we compare 4 of the reconstructed images illustrated here, no filter gives the worst result. RAM-like filter is a result of multiplication of RAM filter with rect function. High-frequency content edges of the image are kept better in the reconstructed image. Hence, as observed from here, the transitions between projections and frequency content is sharper. RAM-like filter is sensitive to noise in projections, so when it is multiplied by a windowing function, better results are observed. For hemming window, extra edges are removed from the image and the transitions between the projections are smoother. Compared to RAM-like filter, when it's multiplied by hemming window, the transitions are smoother, so we can say it is more blurry. Cosine filter is similar to hemming filter in terms of filter response. RAM-like has the sharpest transitions, whereas hemming has the smoothest. Because filter amplitude of cosine is moderate between them, the reconstructed image is parallel to that. To conclude, the goal of this project was to practice theoretical information regarding central section theorem and projection reconstruction methods covered in lectures. In addition, concepts of sinogram back projection, filtered and convolution back projections are analyzed and understood in this project. Simulations of the projection reconstruction method is done. Difference between back projection image and summation back projection image is understood. Effect of number of projections, motion artifacts on the reconstructed image are discussed. Effect of filtering and windowing functions are analyzed. Hence, investigation of the projection reconstruction method, both qualitative and analytical discussion of the method is conducted with theoretical research and MATLAB simulations.